Okay, so today we are starting a roller coaster project. You guys heard, I'm sure you overheard, Len and I talking, how they're getting rid of Firehawk at Kings Island. I know, exactly, right? But the good thing is, the people at Cedar Fairs, they called me, and they were like, we're looking for new ideas for a new coaster to replace Firehawk. And they said, I would like your pre-calculus students to come up with the next new coaster that's going to go at Kings Island. Did you know that me and Kings Island are like that? Yeah. Rachel. Please tell me that I love videos so tomorrow's class can hear that. Rachel was if I'm being honest. Okay, so anyway, since Kings Island totally called me up, Mr. Kings Island himself, Mr. Mike, I don't know who they are. He didn't give me his name, so. Anyway, so what's going to happen is you're going to be in a roller coaster design group. Now, group means it is not a solo project. You will be in a group, 2 or 3 people. That means not 4. 2 or 3 people. If there's a group of 4, then you break apart and do 2 and 2. If there's an extra person by themselves, go make a group of 3 with somebody. Okay, you should not have any issues with groups of 2, not 2 or 3. 2 or 3, okay? So you are asked to come up with a new design. This coaster is going to be built in Kings Island 2020. If your design passes all the specifications, you're going to earn $100,000. It's not bad. Here's your requirement. Your roller coaster concept is going to be a piecewise function, which we covered in chapter 1. It has to contain at least 3 trigonometric functions. What is a trigonometric function? Sine, cosine, all the other ones we haven't learned? Yeah. Okay. It has to be at least 3 trigonometric functions. At least means you can have more. It also means you can have other functions besides trigonometric functions. So if you have 4 graphs, 4 pieces, 3 of them have to be trigonometric, but you could have a parabola in there, or you could have a line, or you can have a square root, or you can have a cubic, or whatever else we covered. You have to contain at least 1 sine and 1 cosine function. So you could have at least 1 sine, you could have more, at least 1 cosine, you could have more. You may have more than 3 functions. You can use other functions from class. Your trigonometric pieces must contain at least 1 vertical stretch or shrink, at least 1 horizontal stretch or shrink, at least 1 horizontal translation, which we're doing today in notes, and at least 1 vertical translation. Your coaster has to be at least 6 pi in horizontal length. It must include negative and positive y values. Your roller coaster has to be a continuous function. So what that means is we can't have gaps, has to pass the vertical line test. So a coaster that would not pass the vertical line test would be an upside down coaster. Sorry, they don't want an upside down coaster. They specifically told me it has to pass the vertical line test. But Kings Island told me that. What? Does Diamond go up back?
No, it does not.
Okay, so yeah, then yes. I haven't written that one last. But the other thing is the no gaps. Continuous would mean like there isn't a hole and then the piece starts somewhere else. Because if you have a roller coaster like this, I'm not gonna write it. Right? Has to be continuous. No, not the kind of coaster where you guys are building. And then the pieces have to connect in a way that allows the coaster to be realistic. So if you have a roller coaster that has an absolute value in it, how's that gonna work? Now, if you can come up with a concept of the way that one can work, fine. But like, if you really want it to be an absolute value, you've got to come up with the way the cars will possibly be able to go on the V shape. Fine. It's got to be somewhat realistic. And since I'm recording the video and nobody can see what I just was saying about no gaps, I was saying where you have a piecewise and it can't like all of a sudden start up there. Like that would have a gap and there's no way your roller coaster is going to do that. So it has to all be continuous. Your roller coaster must start and end at the same height, so passengers can get on and off at the same location. And I can show you guys this. It's going to be harder for me to show this on the video on the recording. But, you know, I gave you that that piece of graph paper, which I thought here is. So if this was your coaster, you guys are going to be putting it on a flat piece of paper. But if I were to connect it, if we were going to make it three-dimensional, then the people would be able to get on and off at the same place. So, same height. What?
So it can't be like flat of paper. They can come off at a different point.
But
you guys?
yeah. Well, I mean, it's connected and it's at the same level.
Okay.
They just get it off at a different part because it's easier to load that way.
Yeah. So ours is not going to be like that. Okay, so you're gonna have to grab, sorry, just hold on. I don't know. Alright, so now, the roller coaster that is, quote, chosen is gonna earn a special bonus of $5,000. So what do I mean by chosen? We'll see it on the next page. The next page says the presentation. That means you will be presenting. Your group is going to create a poster size, accurate graph of this piecewise function. Your group will need to come up with a name and a concept for your roller coaster. The poster will clearly display the coaster track, but it will also have to include design elements to see what your coaster would look like and what type of audience you are attracting to this ride. For example, if you want this coaster to be available for teenagers and adults, you can add in some scary stuff. But if it's designed for kids, don't put scary stuff in it. Right? For kids, maybe lots of colors and cartoonish stuff, right?
Sure. Yes.
Okay, so your coaster has to match your audience. Your poster will clearly display the piecewise function that you use to create your coaster. This, a lot of people forgot to add last year, so just heads up, like you have to put the piecewise function on it. So pick a corner or something to write your piecewise function that you used on it. And then your group will present the coaster poster in front of the class and describe these elements and tell people what's interesting. And I have an example to show you in just a moment so you know what I'm talking about by presenting. And the posters will be hung up for the committee to vote on their choice for the new coaster. So we will be hanging these up, and you will not get to vote on your own. You will actually vote on my other classes, and my other classes will vote on yours. Okay. Desmos. Desmos is an online calculator, desmos.com. You're going to use Desmos to aid your decision and transformations, incorporate your graph. You're going to want to have one group member in your graph in your group create a Desmos account, and just heads up, you're going to use Desmos later in here to do a group that is an individual, not a group, a project that's an individual project. So you're going to have to create an account at some point. Really easy, really easy. Because what's going to happen is you're going to work on this for one day and you want it to save. You don't have to start over. You're going to need to change the X scale by clicking the wrench that is in the upper right corner of the graph, and you're going to set your X step value to pi/2. So I have this. Since I'm recording, I'll just show you real fast, and you guys could go back and watch this later when you actually do it. So I go to Desmos, I start graphing. There's this little wrench right over here. See that wrench? It says graph settings. You're going to go to the X-axis and you're going to change the step to be pi over 2. Once you change the step, you can see that now my graph is counting by pi's, and it's a lot easier for me to like graph trigonometric graphs on there. Okay? So the wrench is where you find that information. And then when you go to type stuff into Desmos, this is telling you how to do it, because you'll be doing this when I'm not here. Here's an example of a piecewise function. This is an example of a piecewise function. This is how you would see it on a worksheet. Down here is a screenshot on how you type it into Desmos. So you see the function, and then you see the domain restrictions, how they're typed in Desmos. So if you want to find out how to type them in, there you go, I did an example for you. And then here, once you've graphed your full piecewise function on Desmos and you're like happy and you're ready to turn it in, there's a way to email it to me. So you'll be emailing it to me when you go to Desmos. There's like an arrow, and then you're going to, you can just send me that link. You can just share that link. And my email address is right here. If you don't know what it is already, it's right there. Okay? The last page is the rubric, and you will turn this in. So don't lose that. You're going to put all the names of the people, print names of the people in your group so I can read it. And then each group member needs to sign it. Please sign it, because this signature is just saying that I'm allowed to share. You're okay with me sharing your stuff. I'm not going to go online and say your name and you know, I just want to, it'll be more like, look what my pre-calc students are doing, and like your graph or something like that. Okay? Or maybe I'll share it to Lakota District, and Lakota District will share it in an email. Look what pre-calc students are doing. Okay? So you just need to sign if that's okay that I share your stuff you came up with. And then everything is that I'm grading is here, so you know, go through this. Use this is like summarized. Really, the best way to figure it out is using this sheet to make sure you've done everything. But this is where I'm going to give you your grade. See, instead of out of points or out of money. See, good. So if you get it all, you get everything right, you get $100,000. But you can earn special bonuses. If you're the class winner, you'll get $5,000 extra dollars. Or if you go way above and beyond, I'll give you some extra money in there too. Okay. So I'm not putting limitations on it. Like everybody could earn extra credit if everybody goes above and beyond and does more than the minimum. Okay. So far, questions on this project? So you probably want to see some examples to get things turning, right? Stuff up there. Go in. So this graph paper that I handed out, this is just for you to kind of sketch what you feel like you want your coaster to look like. This does not have to be turned in. I just thought it would be helpful to have this, and you just take a pencil and start sketching things. And I know I want it to be really big at the beginning, and I want little curves in the middle, or however you want to do it. So I actually did my own. Well, this is not the final product. This is oops, let me see. You can see it. So this is not the final product. This was me kind of using that graph paper that I just gave you to kind of, I don't know why it turned yellow, to kind of just like start figure out what I wanted to do. I wanted to have a big scary hill at the beginning, but a little hill, and then more fun hills at the end. I did totally the bare minimum here. I did just 3 equations. They're all trigonometric. At least 1 sine and 1 cosine, like bare minimum here. And then what I did was I went to my design team and I said, could you actually design the coaster that goes on this track? Did you know I have a design team? I do. You want to see what they came up with? Oh, before I showed you that, I also did it on Desmos and printed it out so you could see, here's the exact same coaster and there's my equations on Desmos. And this stuff will be in the room on Friday if you want to go see it again, but there's also a video. Okay, so I went to my design team and I said, here is my coaster, please decorate it and give it a concept. So my first design team member, his name is Carson. son. He came up with the miner, which is like Minecraft related. So there's like that hammer thing, and here's his actual roller coaster with like Minecraft design on the side of it. And then he said, this is kind of hard to see from where you are, but this says the cave, and then he's got his cave drawn in there. Let me see if I can make this brighter. Oh, oh yep, okay. And then right here, he wrote Harry Potter music. And then this is random music. Over here it says Percy Jackson music. And then here's another card going on the roller coaster. And then there's some scary monster thing that you go through. And over here is more Harry Potter music. Or it says other Harry Potter music. So this is the coaster that he came up with. You can even see, you can see my original design. You can see my original equations. But then he added his design to it. Okay? So hopefully that inspires you. And if not, I had my other design team member draw her. This is Ari's coaster. You guys are like impressed. You're like, there's no way that mine's going to even compare. I know. So the title of her coaster is the Up, Down, Up, Down, Up, Down Monstrous Roller Coaster. And she has right here her actual coaster. There's those like boxes. That's her actual roller coaster with people in it. She even drew people in it, and it has some big scary dragon tail at the end of the coaster. And then over here, there's a tunnel, and there's some scary monster that they have to go through. And then over here is the other. This is the rest of the sometimes more than one coaster is going at a time. So there's the other coaster with the people having a good time. Okay, so hopefully that gives you some inspiration of what your idea could be. I assume hers is for adults because it's pretty scary. And then Carson's is probably for teenagers because you guys love Minecraft, right? Or 7 and 8 year olds. Do you guys have questions about this project as I'm recording? Maybe somebody else has a question. They can't ask me tomorrow, but you could ask me today. Yeah. Well, when I say minimum of 3 equations, and you do 10, that's above and beyond. If you do 4, if I say you have to do at least one sine and one cosine, and then you start putting in parabolas and square roots and like other things that we've done in here, that's above and beyond. Or maybe the creativity of the poster itself. Maybe you're like an art major or going to be an art major someday, AP art student, and you just go way above and beyond with your project. Yeah.
Can you use like
Can you use what?
tangent and stuff?
Yes, but we haven't taught it, so. But you're more than welcome to look things up on the internet, because you're going to be playing around with Desmos, and Desmos has a lot of information in there. Yes, dear.
Are we getting the laptop right here?
So the laptop cart will be here on Friday. And actually, it'll be here tomorrow, too, if you wanted to come in and next and start it. But Desmos works really, really well on your phone. There's even an app. So if you aren't doing it on the cart, you could always use your phone. It works really well on your phone. Thank you. That was a really good question. Other questions? Are they good on the video? Are you excited?
I can
I'm excited. All right. So that will be posted.